So again, we're going to solve the equation first. So I'm going to take this. I'm going to do it in a different color, so I remember that, this. Oh man, come on now. This part's important. But rather than less than or greater than, I'm going to solve it as an equation. So to solve that, where should we start? Yeah, we've got this absolute value expression in here that we're going to have to deal with at some point, but not yet. It's going to be easier to interpret what this thing does and what it tells us if we get it by itself first. So I'm going to start by subtracting 3. And then what else? Divide by -1/2 or multiply by -2 to get rid of that. So the absolute value 2x minus 1 is equal to 4. And again, we talked about this yesterday, but at no point up to now have we done anything with the 2x minus 1, the stuff that's in the absolute value. That's a -2. We haven't touched that at all. If it makes you feel better to, sort of cover it up and forget it's there for now. What you cannot do is move stuff into or out of an absolute value because that probably doesn't work the way that you might think it does. So the absolute value, bars, that grouping symbol, we treat like it's, set in stone until we get the thing by itself, and then we can start to interpret what it tells us. So if the absolute value, the distance from 0 of something that we want to know more about is 4, what does that tell us? That it's either 4 or -4. That what's either 4 or -4, whatever was inside the absolute value. So at the point when I, drop or decompose the absolute value, what we're doing is interpreting what it tells us, which is this, that if this thing is 4 away from 0, it could be either at +4 or at -4. Okay, now what? Finish solving, yeah. So add 1. 2x is 5. That means that x is 5 halves, 2.5. I get it. I didn't do anything this time. I had high hopes for that working. Always something. Oh, it's coming back. I can feel it. There we go. See? Just gotta believe, man. All right, 2x is -3. X is -3 halves. All right. So 5 halves and -3 halves. If what we'd set out to do was just solve that equation, we'd be done. We're trying to solve an inequality, though. So those are important, but we're not quite done yet. Now the inequality. Copy and paste that there. What we just learned is that important stuff happens at -3 halves and at 5 halves. What we want to know is what happens everywhere else, and in particular, where this statement is true. So what I'm going to do is pick test values to plug into that, or again, if you want to think about it graphically, if that makes sense to you, you can do it that way. You're looking for this absolute value function that's got a bunch of stuff going on, including a reflection that flips it upside down, is bigger than 1. What we just found is where they intersect. So if that's, okay with you, then go with that. That's fine. Again, sketch me a little picture or something. Otherwise, we want a little more kind of general or you know, less subtle maybe approach. I can pick some values to plug in from each of those intervals. One of these is negative, the other one's positive, so I know zero's in between them. This is negative 2.5. Negative 5 is definitely further that way. Sorry, negative 1.5. This is 2.5. 5 is definitely further that way, right? And then I'm going to plug those into that inequality and see what happens. Two times negative 5 is negative 10, so that's negative 11. So I get 11 over 2 plus 3, which is, well, 11 over 2 is like 5-ish. Is that bigger than 1? No, because it's negative. All I need is a, thumbs up or thumbs down on whether that's true or not. All this stuff I just did, you can just punch this into a calculator just like it is, and it'll spit out an answer, right? Like I did this by hand, you don't have to. Show me, like write something down that you're actually checking these, that you're not just guessing. But again, you can just type all that into a calculator if you want. That's not bigger than 1. So that interval does not cause this inequality to be a true statement. Can I say it that way? If I plug 0 in, and do the same kind of thing, I get negative 1/2 plus 3, so that's 5 over 2. Is that bigger than 1? Yes. And x equals 5. If you wanted, because, you see here that like we're ending up with kind of a bunch of arithmetic to do, you could do some of this stuff on the front end and move some things around and kind of simplify things before. And then that makes this step a little bit easier. As long as we're careful that we're still talking about the same situation. So negative 1/2 times 9. That's negative 3/2, which is negative, and so not bigger than 1. So what's the solution set to this inequality? Where's it true?
Oh, I'm tripping. You're right.
Yeah. Not true out here to the left of negative 3/2, right? Or out here. So it's going to be a single interval between two things, between negative 3/2 and 5/2, which are the two places that they intersect or cross. Okay. Hopefully you went home and worked some problems and are kind of getting a feel for how this works a little bit. Um, if not, well, you should, and let you have a time machine or something. But you will notice patterns start to show up as you work through these, because an absolute value looks like this because of how absolute value works. A lot of these you're going to see, if there's a solution at all, a non-trivial solution, you're going to see things like alternating, right? False, true, false here, or true, false, true, vice versa. Patterns are good. Patterns are helpful. A lot of math is about patterns. We don't want to overly trust patterns though, okay? So don't get in the habit of expecting that things are always going to alternate and like just test one interval and then say, okay, I know what the rest of it looks like, right? That will, maybe be problematic right now, but it'll definitely be a problem later on. So, just get in the practice of like, we actually need to check what happens on each of these. Again, if you're good with thinking about it graphically and, below, above, below, that's fine. Sketch something like this, show me how you're thinking about it. If testing points like this and kind of doing it numerically and knowing for sure if that helps you feel better about it, then do that. Again, the reason I'm doing it this way is because this generalizes to all the other stuff, right? If you do the thing where you split the absolute value up and one of them you leave alone and the other one you flip the inequality, that's fine. That works. It only works for absolute value stuff, but that's fine. Sometimes you got to survive the thing that's right in front of you. So if you're good with that, do that. That's fine. It's not wrong. It's just not going to help you later. Whereas, again, I'm going to do inequalities the same way all semester. Okay. Any last questions for now, at least about that? Feel good about the inequality stuff? Okay. All right. And then we talked about piecewise functions as well. Again, the main thing to take away from that is how to evaluate a piecewise function. So for, say, this function, if I wanted to find f of 4, what do I need to do? Okay, why? It's greater than 2. Because 4 fits in right there, but not right here or right there. So we just take 4 and plug it into that function because it's the one that fits, right? And then, evaluate as you normally would. 2 squared minus 1, 4 minus 1, 3. That's it. There are a couple in the homework that are having you graph where you're sort of moving the graphs like into place and defining the endpoints. And you'll get a feel for how that works. Again, I'm not going to put that on a test question, but the basic idea is just you take the function that you're given. That one looks something like that, the first one here. And then this just tells you to cut the endpoints off. So at -5 and at -1, there, I guess. I would just get this little chunk. This is closed. This is open. So the first piece of this graph would look like that. Then graph this, but cut the endpoints off. Then graph this, but cut the endpoints off, and you get your piecewise function. It's still a function, so it should still pass a vertical line test, meaning you've only got like one piece sort of happening at a time. And you can hopefully see that if you look at this. Between -5 and -1, then between -1 and 3, then between 3 and 4. There's no overlap in those things, right? That's the vertical line test thing. Okay. Okay. All right. Our last topic for Friday for the test is circles. Circles are things that like we kind of need to know some stuff about and be able to work with them, both because they come up in different places, but also because the standards for the class says we need to. But they kind of also don't really fit in anywhere very well. If you think about a circle, is that a function? No. Okay, so we just spent all this time talking about functions, and now we're going to look at something that's not a function, right? So there's a little bit of weirdness there. But let's start by just looking at one. A little bit of terminology stuff. What is the diameter of a circle? Maybe what makes a circle a circle? Okay, it's the circliness of its shape. Sure, right? How do you get a good circle? Okay, like you want to draw a really good circle and you don't have a can or something to trace. The other option, I should have brought one with me, to use a compass, right? Compass, you got, one arm here and another arm here. You can use a piece of string and you're really pressed for time. Just take out a shoelace and boom, there's your compass. And one end is pointy and sharp, and the other end has a pencil on it. And you jab the pointy end in the paper and it stays still. And then the whole point of the thing is that it doesn't move this way so that you can trace out a circle, right? Okay, well, what it's doing is marking the center. That's where the stabby end goes. And then preserving how far apart the center and the, end with the pencil on it are so that you can trace your circle, right? And that distance is called the radius. The formal definition of a circle might say something like it's all the points that are a fixed distance from a common point called the center. We call that distance that they're all away, the radius. So the radius is the same here as there, and all the way around, right? My circle's not exactly circly, but that's how it's supposed to work. So center and radius are kind of the two defining characteristics of a circle. If we know the center, we know where to put it. And if we know where the radius, then we know how big a circle it is. Those two things together then tell me uniquely that we mean, this circle and not that. Okay? So those are going to be our main focus. If you look at like the stuff that I'm asking for here, we're going to find the center and the radius so that we can describe the circle. Other terminology stuff we need to know though, Emma, you mentioned the circumference. What's circumference? Distance around the outside, right? So it's like the perimeter. If I walked around the outside of the circle, that's called the circumference. One other term we need is the diameter. Which is the distance all the way across. Radius is the distance from the center to the outside. Diameter is the distance from the outside to the outside, but going through the middle, right? So not through, just the side of the circle somewhere. That's just, that's called a chord. Diameter's got to go through the center all the way across. How are the diameter and the radius related? Yeah, diameter is twice the radius, or the radius is half the diameter, right? Okay, so if we know one of those things, then really we know both of them without really needing to do more work to find it, right? Just double it or half it, depending on which one we have. Okay. So plot the points -4, 3, and 2, -5. And actually, let's just take a few minutes for you guys to kind of think through this stuff here. Plot those points. Those are going to be the endpoints of a diameter. So kind of sketch your circle in, connect them with a straight line, and then see if you can make some estimates about the center and the radius. Okay, so we're given 2 points that are on the circle itself, directly across from one another through the widest part, going through the center. They're on endpoints of a diameter, so that's what that means. Draw a straight line between them. That straight line is a diameter then. Sketch the circle. I cheated a little bit because Notability does it for me. So, although sometimes I try to draw a circle and it makes like, did you mean this? I'm like, no, but that's kind of insulting. Thank you. I didn't mean that. Anyway, we get our circle. Okay, we want to first estimate the center. How do we do that? Okay, look at it. It's a good place to start. Where does it look like the center is? There? Okay. How sure do we feel about that? Okay. Why? I mean, it looks right. I did give you a nice, grid to draw the thing on. So if we tried a little bit to draw, use a straight edge or something to draw that diameter in, then like we probably feel pretty good about that, right? Less good if we didn't have the grid paper to work with. Less good if I didn't have a straight edge to help me draw the line in. Less good if the coordinates weren't quite as nice. All right, if it didn't happen to land on a grid point, like if the diameter went through there and this looked like the middle, I don't know. Like then I don't feel as good that I'm being real precise, right? So how could we get a little bit more information to support what we think is the center and feel better about it? Any ideas? Okay, there is a formula for finding the midpoint of a line. Does anybody know it? We remember that there is one. Okay. No, it's not.
Darn it.
Shoot. What's the bad thing about formulas? You got to remember them. And if you don't remember it right, what's it worth?
Nothing.
Nothing. Okay. I think we figure out what it does and why it does. How can we get from the two things that we know for sure, right? Are those 2 points? How can we get from one to the other? We could go in a straight line like we did. Okay, half the circumference maybe. Problem is circumference is even harder to measure because it's a multiple of pi, right? I got to measure a curve thing. That's kind of tricky. We're on a square grid, right? Part of the reason some of the circle stuff gets a little bit tricky is that you're putting a round thing on a square grid. So, I mean, look at these points and think about how many of them look like they land on the nice, grid point. Not very many, right? Because we're putting a circle onto the square thing. But what can we do easily on a square thing, on a square grid? You can go straight up and down and go straight left and right. Okay. So counting how far this diagonal is, that's kind of tricky, but that would be pretty straightforward. How far down and how far over do we go to get from one to the other? Down 8. 1, 2, 3, 4, 5, 6, 7, 8. And over 1, 2, 3, 4, 5, 6. What are we trying to figure out again? Halfway? What can we do to figure out where halfway is? Only do half of that, right? Think about like when you've done slope before and you did the stair steppy, rise over run thing. Kind of the same idea, right? If I only went halfway instead, I would go 1, 2, 3, 4, and then 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. What did we go through in the middle? 1, 1. I went down 4 from 3. So starting at 3, 2, 1, 0, -1. Right, that's down 4. Then down another 4, -2, -3, -4, -5. All right, look at just one coordinate at a time. From -4, I go over 3. Okay, -3, -2, -1. Then over another 3, 0, 1, 2. Okay, yeah, so it's really -1, -1. Okay, but what if I don't want to draw it out and count? And again, like the drawing thing's easier if I've got a square grid, and so is the counting thing. What are we really doing? We're finding the point that's halfway between these 2 points. But let's look at it one coordinate at a time. We're finding the thing that's halfway between those. What do you call the number that's halfway between 2 numbers? Okay, the midpoint, what's its other name? Don't think about it as coordinates. Don't think about geometry. Don't look at a picture. I give you 2 numbers and tell you and ask you, hey, what's halfway between these? Like you've got 2 test scores and you want to know what's halfway between them. The average, right? The average is the thing halfway between 2 things. What's the average? Have anywhere to write stuff. How do you average 2 things? You add them together, you divide by 2. All right, let's try that with these 2 x coordinates. -4 plus 2 divided by 2. What's -4 plus 2? -2 divided by 2. Oh, hey. And why? 3 and -5. What's 3 plus -5? Divided by 2. Oh, hey. I've seen those show up before. Midpoint formula is just the average. Sabrina, do you want to fix it now? You add the coordinates together and divide by 2. Because what is it really doing? Taking the average. That's all. Okay? Do it. I know. I know. But the point, being close with a formula is not really any better than, not even being in the ballpark, right? As far as, what it actually does for you. Okay. So yeah, there's a midpoint formula, but really what it's doing is taking the average. And average is a thing you know how to find. So I mean, for me, I would probably not try to memorize it as a formula because, like, then you're not really you're kind of separating it from thinking about it. If you think about what it's doing, what it's looking for, I think that's an easier way to go. But the center is -1, -1, and there are a bunch of reasons why. Okay? Pretty good so far. Okay. What else do we need to know? The radius. Same picture, so let me make some space here. How can we find the radius? First of all, where is the radius on the picture? Sure, anywhere. In particular, there's one, right? That's a radius. It's any of them, but let's use some of the points that we already know, right? So that's a radius. This is also a radius, but there's one there. Radius is the length of that line, meaning it's the distance from, what point to say? It's the distance from there to here. Hey, there's a distance formula too, right? Anybody remember it? Okay, if you need it. I mean, I do, but you know, for the purpose of the story, I don't. How can we figure out how long that line I highlighted in pink is? If we don't know the distance formula, which is some kind of weird thing with square. You wrote something down. Okay. Don't be scared. How can we figure it out if we don't know what formula it is? What else do you see there? Okay. Rise over run. I'm going to zoom in a little bit. We're focusing right here, right? Rise of 4 to a run of 3. Okay, so that tells me about the slope. If I do the rise over run, that tells me, you know, how slanty that line is. Doesn't tell me how long it is, though. What else do you see? A triangle, right? What kind of triangle? A right triangle. And since birth, I think, if I'm remembering right, I think that was while we were still in the hospital before we brought the kids home, we taught them the Pythagorean theorem. What's the Pythagorean theorem tell you about right triangles? That the sum of the squares of the two sides gives you the square of the hypotenuse. C is the longer one, so the one across from the right angle. These are the two legs, A and B. For this triangle in particular, what are A and B? 3 and 4. Does it matter which one's which? No, you're adding them together anyway, so doesn't matter. C squared, but C really is the radius that I'm looking for, so let's just go ahead and call it R. 9 and 16, so 25 is R squared. What's R then? 5. Because there's a triangle there. There's a reason that the Pythagorean theorem gets so much, you know, like if there's just sort of random math symbols in like the background of something, the Pythagorean theorem is almost always there, right? Like if math comes up in a, I don't know, TV show or something, like the Pythagorean theorem's part of it, but there's a reason, right? It's important. You guys that go on to pre-cal, basically the entire class is just the Pythagorean theorem, just from a whole bunch of different perspectives and what you can do with it. So it comes up here too. We get this right triangle. The legs are 3 and 4. We want the hypotenuse. So we plug in, we find it. Now that distance formula thing, where's some empty space? Nowhere. If you're a formula type person, distance formula says if you've got points x1, x2, and y1, y2, and you want to find how far apart they are, d for distance, not for diameter here, then you take the square root of x1 minus x2 squared plus y1 minus y2 squared. Well, what's that doing? Look just at this part. X1 minus x2, that's how far apart they are just in the x coordinate. Squared, that's counting over and treating it like the leg of a right triangle. The length here is x1 minus x2, and the length here is y1 minus y2, and the distance, the thing that we want, is the hypotenuse of that right triangle. This is still just the Pythagorean theorem, only with generic labels on it that make it look scarier. So I'm not gonna, judge or count right or wrong if you use this as formula versus if you just draw a triangle and use the Pythagorean theorem. I think I'm making it obvious that I think just drawing a triangle and thinking about it is a better way to go than trying to, memorize some arcane formula that you only need one time. But, you do you. But that's where it comes from. The distance formula is just writing the Pythagorean theorem down, solved for the hypotenuse, and with generic labels for everything. Okay? Which is pretty much the same idea as what the midpoint formula does. It's just writing down the average, but with generic labels. Okay. Yes.
So, but if we don't have a perfect point like 1, 1, can we still do the correct Pythagorean theorem and get a reasonable answer?
Yeah, right. So, at worst, you might end up with something like, I don't know, let's say like 2 squared plus 4 squared or something equals r squared when you count, over or something like that. So 20. Well, that just means that the radius is the square root of 20, which you can simplify down further a little bit, but that's not really important right now because we're going to end up squaring it in a second anyway. So, it may not come out exactly like 3, 4, 5, like a Pythagorean triple, but it still works.
Well, that did answer a question, but I was talking about like we have a point, like for some reason you give us -5/2, comma -1. You can't really count this.
Oh, okay. Yeah. Yeah, that's a good, so if, basically like if this was 3.5 or
Yeah.
something, yeah, it still works. It's again, just not gonna be quite as like pretty, right? Really what we're doing is figuring out how far apart the Y values are. So you can do that by counting, or you can just do it by subtracting, right? And then same idea here for the X values, either by counting, which, if we're looking at a square grid, the counting idea makes a lot of sense and is maybe more straightforward, or you can just get it by, how far apart are those? Yeah, same idea. Okay. Cool. So we've got the center, we've got the radius. Center was -1, -1. Radius was 5. Only other thing would be how we write down the equation of the circle. The standard sort of general form for the equation of a circle looks like this. I'm going to write it down, but again, don't panic, don't be scared. Thing involving x squared plus thing involving y squared equals r squared. Where have we seen 2 squares added together equal to another square again? That's the Pythagorean theorem again. Only variables for x and y, h and k, some parameter thing. This is just the Pythagorean theorem again, because what's constant for a circle? No matter where you are, the radius, the distance from the center to the outside, stays the same. So if x and y are the coordinates of all these points on the circle, the thing that stays fixed is that radius. So anywhere I was, I could draw a triangle, and even if the legs aren't nice round numbers like they were here, the thing that they would still have in common is that when I square them and add them together, I still get the square of the radius, right? Because that hypotenuse thing doesn't change. So the way you handle this is that these are the variable parts. And then h and k are the coordinates of the center. And r is the radius. This is really then just doing the same thing as transformations typically do, right? X minus h grouped together inside the square. What should h do if I think about it in terms of transformations? Like x minus 2 or x plus 1 grouped inside with it. Shifts to the left or right, depending on if h is positive or negative, right? So if this is x minus h, it moves to the right. If it's x plus h, then it moves to the left. Okay, so that's the left-right shifting part. Y minus K. This one's a little bit weird because we're used to seeing them on opposite sides of the equation and now they're grouped in together. It's with Y though, so it does vertical stuff. Since they're grouped in together like that, it works the same way that horizontal stuff normally does. So subtracting moves up, adding moves down. Again, I know that's backwards, but it's because it's in a different place than we're used to seeing. So the equation for this circle would be x plus 1 squared plus y plus 1 squared equals r squared 25. Those are the xy coordinates of the center with opposite sign because of the shifting thing and that they're grouped in together again. And then the radius, this is the square of the radius because it's the Pythagorean theorem. All right. What do you need to be able to do with all this for Friday? Given endpoints of a diameter, figure out how far apart they are, figure out what's halfway in between, and write down the equation of the circle. So more on the equation thing. Oh man, why is that not where I think it is? Okay. What's the center and the radius of this circle in part A? The center is 2, -3, and the radius square root of 16, so 4. What's the equation of the circle that has center 0, -2? The equation of a circle looks something like that. Go ahead. Okay, so really just x squared. Yep. Minus -2 or y plus 2. And then the square of the radius. So if we know the equation, we should, and you got to do a couple to sort of train yourself on it a little bit. But if we have the equation of the circle, this information is just sitting, right? We just kind of read it off. Again, I have to do a little bit in, sort of flipping the signs here because this -2 is really shifting to the right. This +3 is really shifting down. But the center's 2, -3. And then the square of the radius, I think it's square root. Or if I know the center and the radius, we can pretty much just write the equation down. All right, I'm doing a little bit of stuff to kind of clean it up, but we're not really doing any work to come up with that. And then the last two, find. That's not how the alphabet goes, I'm realizing now, but letter C wronged my ancestors, so I just, I don't use it. Find the equation of the circle where the diameter's endpoints are here and here, or find the equation of the circle where the diameter's endpoints are here and here. We got to do two things. We got to find the center given by the midpoint or the average. We got to find the radius, which is the distance, which we can get from the Pythagorean theorem, and then write the equation. And similarly for the last one. It might be helpful to, you don't have to, but if you sort of sketch these out and look at where they are in relation to each other, sometimes that helps a little bit. If they happen to be on the same level horizontally or vertically, it kind of saves you a little bit of trouble, because the reason that we really had to get into some of the stuff we got into in that first example is because we're moving diagonally across the square grid, right? So we can't count. If you're just counting over or just counting up or down, you can just count some of the things and figure it out that way. right? So we save ourselves a little bit of trouble. Okay, that's it for today. So finish those up. Thursday, we will talk about one of those quickly, make sure we're on the same page there. And then talk about whatever else you guys want to do, to prepare for Friday.